Okay, I'm going to share the screen. And now we're here in the Jupyter Notebook section. So we're going to build our brand new model. With the other class, and I did this, we got as far as completing linear regression. So I'm going to call this linear regression, okay? And then from there, we're going to build MLP will be the next one, and then deep learning and all that great stuff. And all of it is just for our regression. All we're predicting is wine quality. And we're going to build ever more complex architectures, right? So you're going to see the beauty of neural nets and deep learning just to predict wine quality. All right, so let's go ahead and do that. Let's add a whole bunch of cells here. I'm going to rename this one as I called it, regression linear PyTorch. Regression linear PyTorch. Okay, let's rename it. A few more cells in here. I don't know why. Huh. What's it doing? All right, there we go. Okay, so let's start with, a comment. That's usually a good idea. So I'm going to say here, linear regression model. Linear regression model for wine quality. Okay, so that's the model that we're trying to predict. Let's start with the libraries. Okay, so I'm going to say libraries that we're going to use. Okay, and the libraries that I want, which should all be installed except for one. We're going to install a new one. So just do exclamation pip install. And I'm going to add this very nice library called ML extend. And you'll see this is really useful for visualization and things like that. Because one of the things you might want to do before you build a model is actually look at the correlation between the inputs and the outputs, right? So we're going to build something called the correlation matrix. It's a very useful tool to kind of like figure out what's great about the relationship, what inputs are useful to predict wine quality. So let's go ahead and hit ML extend. This, I should say, this is one of the most important lectures this whole semester, right? Because this is really showing you how to do it in the easiest way that I can think of, which is regression. And then from here, we're always going to be repeating this process, just adding more complexity to it, like filling it in, right? More and more and more and more and more. And so it'll get pretty complex eventually. But the overall skeleton is always going to be the same. Okay. Anyway, so I installed the library. So now you can go ahead and just add the comments over here. So we know we've got ML extend. So now let's add our libraries. So you might imagine import NumPy as NP, import torch. So that's another one. We're going to use pandas for this. I like using pandas. I think we've read in a previous example, we read a CSV with NumPy, right? And we have to do some things. And now we're going to read in the same CSV with pandas, and you're going to see the contrast of it and why it's kind of it's better, right? So you'll see it's like if you've ever done SQL, SQL or Excel, it tries to mimic those tools a little bit more. So it gives you a little bit more power. So pandas, I believe it's installed already. It's going to tell us in a second. We're also, oh yeah, I'm going to use sklearn. So sklearn is a very useful tool in machine learning that has a lot of handy functions, right? So a lot of the time you end up taking a tensor, converting it to NumPy, and then just running with sklearn, or starting with NumPy, doing sklearn, and then becoming a tensor. Now this can be done all with Torch, maybe, but in general, people, you know, have a preference to do things in NumPy and sklearn, and that's kind of how I'm doing. Okay. Questions over there, guys? Questions? All right. So also we're gonna need random. So import random, and that's basically because we're gonna want to initialize some of the data randomly. All right. So run and install your libraries, and let's see if it breaks at some point. Pandas is the only thing that would cause it to break, I think. All right, good. So I have pandas, it seems, in this environment. So now let's go ahead. We're going to need more libraries, okay? As we start building our neural network. If you remember, in the Celsius to Fahrenheit, we had Optim from Torch. So we're going to need that, but let's wait until we need it. So these are just some of the basic things. So the very first thing I'm going to do is I'm going to read the data. That's what makes sense. What's great about this making a model is it kind of tells us what it needs, right? You get to a point and you're like, okay, I need to do that part or this part. So, but usually a good starting point is your X and Y. Remember that, creating that X and Y? So we're going to do that, right? That's basically the objective first. So we're going to read the data, let's call it. Okay. And so let's do cell type, markdown, hit run. Okay. And now we're going to read in our wine data. So let's say path data. Guys, any questions over there? Do you guys have any questions? I'm sorry. I hear you talking quite a bit. Do you have any questions? All right. So we're going to read in the data, right? So data / wine quality. So this is the CSV that we looked at last week. All right. So wine quality.csv. Okay. Notice the single quote here. Let's fix that. Okay. And we're going to use pandas this time around. So let's create a variable called wine _ raw data. And this can be any name that you want. So actually, you could probably use Ph.D. or you could use DF. And DF stands for data frame. All right, just to be consistent. And this is just tells you that this is a pandas data frame. And if it is a pandas data frame, then you can do a lot of operations with it related to pandas. Okay, so we're going to do Ph.D. dot read _ CSV. And we provide to it the path data. Okay, so let's go ahead and try to do that. That's the first step, right? Just to read in the data. Okay, gave us an error. No such file or directory. So where is, do I not have it? Oh, I created this in the wrong place, didn't I? Yeah, I added this script and where the data is by mistake. Do you guys see that? I guess it doesn't matter. Let's just then assume it's here, but really I should have done it outside. All right, so then the file is right here, wine quality. That's in the local directory. So I'm just going to remove that. Got it? All right. Sorry about that. All right, so let's try it again. So I'm going to hit save, hit run. Okay, right? So it read the data. Now let's view the data in the Jupyter Notebook. So I'm going to do wine raw data df to indicate it's a data frame. Hit run, and you can see it creates this really nice like a data frame on the screen of the Jupyter. So what do you guys think? If you look at it, what do you see? Yeah, go ahead, please. It's broken. There's one. So if you, oh, good observation, right? So it says 4898 by 1. So it put all the data in one column, basically. Why is that? Because the delimiter, if you look closely, seems to be a semicolon. If I go to the data over here, oops, sorry. Click on this one. The delimiter is a semicolon. Do you guys see that? But by default, pandas is CSV. The name implies comma separated, so it's expecting a comma, right? So that's the problem. But we can fix that one probably. So let me close this. So let's go back to our Jupyter, and these things have parameters. So we can say delimiter equal double quote, and then it's semicolon. Do you guys see that? Now, in the past, we had to remove or skip the column names. Do you remember that when we did this before in Numpy? Because Numpy only accepts numbers. Pandas allows the columns to remain. And that is really nice, okay? Because we actually want to know what we're looking at. And so we want to keep the names. So we're going to, rerun this. So I'm going to run that one and run that one. And as you can see, our data now looks really great. Okay, so we've got our data. We can confirm it's 4,898 rows by 12 columns. We know that the last one is quality. That's the thing we're trying to predict given fixed acidity, volatile acidity, and so on. Got it? All right. Any questions so far, guys? All right. So we've got that. What else do we want? We want to look at the columns. We want to store those in a list, for instance. And that's useful because we may, in the future, just want to look at certain columns and not other ones, right? So we can create lists of column names that we want to look at. And that's really nice. But there's a lot of power in pandas. I mean, it could take us a whole semester to go through it. So I highly recommend that it's something that you always pay attention to. So let's create a list. Let's call it headers list. Oops. List, and basically we can grab all the values from the pandas frame. That's probably the easiest thing. So let's do wine raw data dot, and then we have columns. We want the values, and then we want values plural, and then we want to make this into a list, as in a Python list. Okay, so that is stored in headers list. So now let's just print headers list. And we should be able to view them. Oh, yeah. 2 lists. Sorry about that. All right. So let's run it again. Nope. Wine raw data df underscore d. Yeah, df. Let's try that one. There we go. So we've got our variables there, okay? And so let's now, to show you what I mean, let's create a second list of only like half the variables, okay? So I'm going to create one like manually. I'm going to call it, just to show you some of the power of pandas, I'm going to call it headers list 2. List 2. And I'm going to like manually create this one with just like the, let's say the last, started density. So I need to add square bracket. I need to add this. So I have density, pH, sulfates, alcohol, and quality. Make sense? So I grab that. Oops, let's get rid of that. Printed. So I have a second list, right? So I have 2 lists. And now I want to kind of do some analytics. This is like data science, right? We're going to do some data science on this data set. And so let's motivate it by asking you a question. So let's say that you've been tasked with investigating this. You work for some wine company, I guess. Which one of the factors here do you think has the most influence on wine quality? And hopefully we don't have wine experts here that will tell us all this is wrong, but so which one of these would you say has the most? See how it starts to get interesting, right? So you start to think about the usefulness of it. It's like, you know, we don't have money. Let's imagine you have to send all of these to a lab, and the lab is going to charge you to do all these analyses, right? And so you want to just say, maybe we don't have money for all of these. So which ones are the most important? So my question is, which of these would have the highest impact on quality? Yeah, go ahead. Okay, so you're actually trying to figure out the pattern, right? That's what you're trying to do. You're looking at free sulfur dioxide, and you're trying to compare it to the quality column. Yes, okay. I don't know. So what you're doing is I let machine learning figure it out, right? I let data science techniques and so on figure it out because it's difficult. I don't know. Also, you're only looking at 10 out of 5,000 examples. They're not even random. You're only looking at the first 5 and the last 5. So you'd want to randomly pick them and all that stuff. But yeah, great. So we don't know. That's the question. But it's something that our tools can actually answer for us. Okay. We don't even need to build a model to do this. Like a neural net, we can just use techniques to just look at the data and give us a response. Okay. So that's what I'm going to show you right now. I'm going to show you one nice tool called a correlation matrix, which is something that's highly recommended that you use when you're doing this kind of work. So we're going to do, and I'm going to show you also how pandas can take 2 lists at the same time. All right, so let's go ahead and do that. So I'm going to call this one like data science. So it's 6:10. Tell me at 6:20 to stop. Okay, we'll take a 10-minute break and then come back. All right. So let's call this data science over here. And we know the question we are trying to answer, right? What is the variable that is the most important, you know, to determine the quality of your wine, for instance. Do markdown, run. Okay. So how do we do it? The best way is to build a correlation matrix, which is a visualization tool, actually. So we're going to build a correlation matrix. And this is just a tool in statistics and machine learning that we can use. We want to visualize it, and we're going to use Numpy, and we're also going to use MXL extend. So we had installed that library. So we're going to make use of it. So it looks very presentable, right? Very presentable. So I'm going to go over here if you notice. Now, I already know that I already installed ML extend. Okay, so let's do from ML extend, dot plotting import something called a heat map. Okay, which, you know, as the name implies, it shows you like contrast, etc. So let me run this. Okay, it finished. So that's good. Another thing we're gonna need is matplotlib for this one. So let's do import matplotlib dot pyplot as PLT. Okay, so we're also going to import that one. And I think that's all we need. Okay. And this is just so that we can do the correlation matrix, so it looks pretty nice and presentable. It's the kind of thing that you can put in a report and just show it to people, and it's going to look really nice. All right, so we've done that now, and with 3 lines of code, we'll be able to implement basically our correlation matrix. So Numpy will be the tool that we're going to leverage that has the correlation matrix function. So let's go ahead and do cm dot, we're going to create a variable cm. We're going to invoke numpy np, and we're going to call coef, so for correlation coefficient, okay? And that's basically it. And then after that, we just have to give it the data, okay? And then so we're going to do wine raw data. Okay, now notice what I'm going to do here. It's a little trick. This is kind of where we would index or slice, right? You guys know whenever you see square brackets, that's kind of where we're going. But in pandas, you can do that with words. Great thing, right? So notice I have 2 lists. So I'm going to do it first with headers list and then with headers list 2, just so that you can see that you can select the columns. So here I'm going to do headers list, as just like that. You see that? And then we're going to do, now this is still a pandas data frame. So then we have to say values. And then this T is probably, I think, a transformation. So we're probably flipping it somehow. I know it doesn't work without it. So once we do that, we have the CM object, and then we're just going to run it through the heat map. And that'll just make it really nice and presentable. All right, so I'm going to do HM equal heat map, which is the thing we imported from MXL extend. And we're going to provide to it CM, the thing we just got from Numpy. Does this make sense, guys? This is how it works with machine learning. You leverage Numpy, and then you use some other thing for presentation and visualization. Now, the last part is, we'll add a few more things, but the last part is we're going to use matplotlib to show it. Just like that. That's it. So now remember the question. We want to know what might be the variable that's best correlated, or no, my question was, what is the variable that could influence the quality, right? Another way of saying that is which variable is more correlated or less correlated, right? So let's go ahead and do that one, see if it works. Doesn't work. Oh, the df, yeah, keep forgetting it. Df, try it again. It's thinking, processing. Ah, there it is. Okay, so that's a correlation matrix. It's got values, it's got coloring, right? But can you answer the question? Not yet, right? Because first of all, we don't know the variable names, right? And it's too small, so we can make it possibly bigger. So we can go to the heat map and specify, we're going to do comma, and we're going to specify row names. And what is row names going to be equal to? Headers list. Headers list. And then we're going to look at column names. And what is that one going to be equal to? Headers list, because that's what we're going to be comparing. So we're comparing everything in the list to everything in the list by name in the pandas data frame. Okay, so it's going to do that. And then we can also change the figure size. So fig size. And you can play with these values. I kind of arrived at these, which worked for me. Okay. Any questions? Yes. From MXL extend. So if you notice here, I did from MLX extend dot plotting import heat map. Do you see it? Are you doing it like this from MLX extend plot dot plotting?
Yes. Now saying that from MLX extend no model name. You know, himself.
I don't know. I mean, how about the rest of you? Did it work for you? It's not working for, it's working for you? It's working for you, right? And you're using a local Jacob, right? It works for him. You both have the same thing.
Yeah, install here. And then.
Like L and L.
Yeah, I didn't know.
No, I mean, you can look at it in the break. I don't know. The prompt, yeah, here, yeah, right, you guys look, okay. All right, so let's kind of try to get to the end of this, and then we'll take the 10-minute break. So what have we, yeah,
There's a typo at the end. You go to the,
at the bottom of mine?
yeah, the schema, header column names, headers.
Underscore, right?
That's-
Yeah, okay. Yeah, thank you. All right, so let's run this one. So this is what we were running, right? So let's go ahead. It's thinking. All right, and as you can see, this one is much nicer, right? If you look, it's bigger. We can see the values better. And we've got the variables on both sides. So now you can actually do some data science and actually try to answer the question. Before we do that, let's just change headers list from 1 to 2. Okay, just so I can show you the difference. So now run it.
Change the row names.
Oh, yes. Headers list 2, headers list 2, good catch. All right, so let's run it. And as you can see, it only shows the variables that I've selected. So that's really nice and powerful. Okay, so you want to maybe focus on just that part, etc. Now let's go back to how we have it, what we want. And let's try to answer the question, right? So can we answer? So how does this work? So the correlation coefficient, basically, if you notice here, it's got a bar from +1 to -1, basically. It goes now, and there's 0 in between. And the colors obviously correspond. So if it's dark blue, it's like negative. If it's like yellow, it's 1. Now, 1 means a perfect positive correlation. All right. And -1 means a perfect inverse correlation, right? So it means one thing goes up, the other thing goes down, or the other, or in the previous case, both of them go up. Now, if it's 0, what do you think that means? No correlation. So there's no relationship whatsoever. Do you guys see that? So then, looking at this data, what would you conclude? Now you can actually say something about the question that I had initially. What would you say? Which one of these variables might be the most correlated to, now keep in mind, to the output variable, right? What's the output variable? Quality. So then you can look at this column over here, right? And then what would you say? Now, if it's +1 or -1, that's perfectly fine. It just means that one is, as one goes up, the other one goes up, or as one goes up, the other one goes down. But there's still a very strong influence, right? So either one is fine. Bad thing would be if it's 0, then there's no correlation. So in this case, which variable is the most important or most correlated to quality? Which one? Alcohol. There you go. So now you can actually answer the question like correctly. Do you see that? This is really useful, right? And are there any variables in here that are actually not correlated at all to quality? What would be one? Or there's a couple, right? Citric acid has no, it's minus 0.01. And then there's free sulfur dioxide, which is 0.01. Do you see that? Was that the one you had said? Yeah. So you actually gave, this is actually like a lesson, right? So in the meeting, initially you gave that by looking at the data, just kind of like using your pattern recognition system. And then now you trust data science tools, and it turns out it actually tells you that's not at all a good variable. Nice. Yeah, that's a good, you'll remember that. And so with this tool, you can actually, whenever you're looking at this type of data, regression data, I strongly recommend you always run the correlation coefficients matrix. Boom, you'll be able to really talk about your variables. You haven't done any AI really. This is more like data science, no predictive modeling, but yet quite powerful. Later on, we can look at other techniques like for feature ranking, etc. And there's a lot of that as well. Okay, but this is a good tool. Obviously, why is the diagonal yellow? Same variable, so it's obviously 100% correlated to itself, right? So the diagonal is always yellow. But the color coding is very useful because it really quickly, maybe you're looking, let's say you're looking for inverse correlations, right? So you look for the dark purples and you can quickly zero in on this one. For the quality, you'd be like, maybe that one. Okay, so you can really quickly start to say things about your problem. Does this make sense, guys? Any questions on this one? All right, so this is a good stopping point for the 10-minute break. Okay, so we've done some data science, and then once we come back from the break, we will talk about starting to build our model, all right, our linear regression model. So I'll stop the video here.